This is the lesson plan assignment video presentation for curriculum development for technological studies, part 2, 5387 with Bob Savick. It's Everest Beneteau, and my lesson plan is on machine exploration for the manufacturing lab for TMJ3C. So grade 11's going to the college level, expected in the college level curriculum. The expectations are, let me open this up, from the curriculum, health and safety and tools, equipment, and machine processes. Most of the expectations are from these two areas. So mostly focusing on safety and tool identification, properly using machines in the lab atmosphere. So upon successful completion, they'll be able to understand the specific functions of various workshop machines. I could read all that to you, but I think I'll save it. So in the best case scenario, they'll develop skills in diagramming and technical writing. If they do the more advanced part of this lesson, recognizing the safety protocols with each machine, and maybe having them think of some that aren't listed, possible safety concerns. And so for a 75-minute period, I would have them start in the classroom. Here's some of the multiple intelligence integration, visual, spatial, creating a clear diagram, visualizing the possible hazards of using the machine, determining the limits and permissible sizes of workpieces for each machine, using communication to describe the proper use of lathe, mill, grinder, drill press, whether in the form of verbally, like doing it in a presentation, or writing it down in technical writing. Bodily kinesthetic manipulation of the machine using coordinated movement. Some of the machines, like the Bridgeport and the surface grinder, require you, well, even the lathe also require you to use both hands at once, or even a foot movement to use the brake. So there's a lot going on at once. There's a lot of bodily kinesthetic. So starting off in the classroom, you begin with a video showcasing the various machines. Like these students coming in grade 11, they've already worked on machines a little bit. But I guess you can't rely on that. So we're giving them a refresher for the ones that have already done it, and giving them the ones who haven't done it already. I mean, I believe there is a prerequisite to this where you have to have been in the shop atmosphere before. But either way, the differentiated instruction in this lesson will allow for a variation of learners, people at different levels can catch on at their level. So in the opening, it's going to be a little bit of a diagnostic, a brief discussion about their experiences with the different machines. Begin with the video, have a project to pass around. I have that in tools and materials. So all of that's a sample project that uses most or all of the machines in the shop. So it's something that starts with round stock and finishes with grinding So saw cut, using the lathe, and then milled, and then perhaps surface ground. So having a a, a piece that uses all those processes would be useful to pass around the classroom and pose the question. Well, maybe not this question, but similar ones like, where would you begin with this part, and why is it important? I mean, in your culminating project, you're going to be using all the machines, and designing the culminating project for that year would of course include all the machines, so they're getting a broad experience. Okay, and then I would get on one of the machines and give them a little, like, maybe not actually milling something, but showing them, you know, what ask them what they know about it. What's the main function? Can anyone name the parts of this machine? What additional PPE or safety considerations do you need? Like, sometimes you need additional PPE, like if you're using the welder or something. You'll need the thick gloves. You'll need the darkening mask. You might even need a leather to protect your pants and your shirt. Okay. And then I would have them move into independent practice. Choose a machine from the workshop and create a detailed diagram. This is where I would have them like, I would prefer if they drew it themselves, if they drew the machine, so that they would really, I believe that would really help in them getting to know the machine, like perhaps even finding details of the machine that they've overlooked. So sometimes if you look at the same machine over and over again, there's just some features you don't use that you just don't notice. And then label each part and write a brief description of its function, like the spindle stop, the reverse switch, the there's a stop and a limit that's adjustable on the and of course I would provide these. I have in my tools, my instructional resources, the user guides for the machines, the Bridgeport. You notice the year here. This has been unchanged for a long time. So having them label all these parts, the important parts of, how you bring the spindle down with this lever, and what's this for back here? They may have never used this lever back here. They might even not even know what that's for. This is the reverse button, I think. Yep, this is the spindle stop, the brake. This adjusts so just labeling all the parts. Maybe later on we could get into like the maintenance of the machines too. That would be that's something that's also in the curriculum, but for another lesson. Back to the lesson plan. So I also have it for the lathe, and I would have it for all the machines in the shop, and they could really go through. A lot of this is not needed. Maybe I'll just give them the pages that have the useful stuff on it, like starting with this page where it labels everything. It tells you what it is. Yep, there's more, and these little placards that show what spindle speed you want. So there's A1, B2. All these correspond to different spindle speeds from ABC 1, 2, 3. And then you get into speeds and feeds down here. Feed per revolution is how it works. It's millimeters per revolution and inches per revolution. So yeah, it shows you cross feed and forget what the other one's called. But anyway, and the types of threads you want to do. Here's the pitch of the thread. So if you want to do all that kind of stuff. So maybe some of the features that they're not too familiar with. Mounting a 4-jawed chuck, that's very useful. Oh, there's the chuck key in the spindle. That's a big no-no. You can't have that. And maybe for the people who are really like familiar already, they could say, hey, maybe if this steady rest is missing and they want to use it this year, they could say, oh, that's missing. That would really help out in the shop environment. So having the ones that are new to the shop will obviously just do a different version of this lesson where they're just getting familiar for the first time with these tools. And the ones that already have this familiarity, they can they can do the more advanced. Have them examine and determine safety considerations. Have them determine the largest workpiece that can fit the envelope of the machine. And the history, and then further, the history and evolution of their machine. Like the lathe has gone through a lot of different iterations throughout its history, and the mill. And the surface grinder is relatively new in the history of machining. Their assessment would be based on their picture, their diagram. They have to come up with at least, I would say, depending on how long, I would really have to judge how long the period would allow for how many machine functions and parts that they'll label, and then hopefully they have time to do all of this and then some. So they'll be put into groups, but it depends on the amount of machines in the shop and the amount of students in the classroom. So you would do it in such a way where all the students at one machine are perhaps working together, or maybe they just do it all on their own. I'm not sure. In that case, if I was having them all do it individually and not in a group environment, I would provide them with the handout with some blank spaces in it, so they don't have to draw it, to save some time. Not everybody has that skill of being able to draw like that. And then afterwards, they would hand it in. Did they list 5 components? And were the illustrations clear? I think that would be your rubric for the first part out of 4. 1, 2, 3, and 4 marks. Did they demonstrate the knowledge of the part and its functions? And were any safety considerations? That would be all out of 4, 8, 12 marks. So a mark out of 12 for the end of the day. And I think that would that is it. And I would obviously write down any considerations, and I would adjust as needed. Obviously, it's not going to be perfect the first time, but having a full period to do this, I think it would. I would just have to adjust it to their ability and the future ability of future classes, and have considerations for that. But I believe this would take all different levels of learners into consideration. Thank you.